class we shall discuss about Perkin reaction. Let's start. The condensation of an aromatic aldehyde with an acid anhydride in the presence of sodium or potassium salt of an acid corresponding to the anhydride, which acts as a base to form an alpha beta unsaturated acid, is known as the Perkin reaction. That means an aromatic aldehyde, let's see the example, aromatic aldehyde with an acid anhydride. Now this is the acid anhydride in the presence of sodium or potassium salt corresponding to the in the presence of sodium or potassium salt of an acid corresponding to the anhydride. Now this is the sodium salt corresponding to the acid anhydride, which acts as a base. This acts as a base to form an alpha beta unsaturated acid. To form an alpha beta unsaturated acid, that is cinnamic acid, is known as the Perkin reaction. Here we take benzaldehyde, which is the aromatic aldehyde, and acetic anhydride. In presence of this base, which is CH3COONA, which is the sodium salt of the this anhydride, acetic anhydride, corresponding to this acetic anhydride, we get and in the presence of water we get cinnamic acid and acetic acid. This reaction is known as Perkin reaction. Now let's see the mechanism of this reaction. The mechanism of Perkin reaction. In the first step, alkali salts of acid breaks down to form acid anion. Now, in the second step, the acetate ion reacts with anhydride and forms acetic acid and a carbon ion. Acetate ion abstracts a hydrogen from here and it forms acetic acids and a carbon ion forms. Here a negative charge arises and the rest will be the same. CH2 minus, C double bond O, O, C double bond O, CH3. In third step, this carbon ion reacts with benzaldehyde. Here, this carbon ion acts as a nucleophile and it attacks the benzaldehyde. Here, this negative charge attacks the carbonyl carbon and this double bond shifts from here to the oxygen. And as a result, we get the alkoxide ion. Here, the benzene ring and there CHO minus and these attach here CH2, C double bond O, O, C double bond O, CH3. Alkoxide ion is formed. In fourth step, alkoxide ion abstracts a proton from the acetic acid. In fourth step, the alkoxide ion abstracts a proton from the acetic acid and we get a beta hydroxy anhydride. Why we call this beta? Because this carbonyl carbon, this is carbonyl carbon and this is the alpha carbon and this is the beta carbon. So in the beta position a hydroxyl group is present. So this is called beta hydroxy anhydride. Now in the next step the beta hydroxy anhydride undergoes dehydration and this hydrogen and this oxygen and this hydroxyl group combine and one molecule of water removed and we get CH double bond CH, C double bond O, O, C double bond O, CH3. And in the sixth step, hydrolysis occur and this bond breaks and H, here H and here OH added and we get cinnamic acid and acetic acid as Perkin reaction product. Now let's see CH, C double bond CH, C double bond O, OH and here CH3, C double bond O, OH. Now here we get this product. The carboxylate salt corresponding to the anhydride is generally used in the Perkin reaction. Now why? Why we use the carboxylate salt corresponding to the anhydride generally in the Perkin reaction? Now, if a salt of an acid not corresponding to the anhydride is used, the following reaction may take place at higher temperature. Here we take 2R-CONA plus RCO whole triiso and we get R-CO whole triiso plus 2RCONA. As a result, both the anhydride condense with the aldehyde to give a mixture of products. As a result, what's happened? Both the anhydrides condense with the aldehyde to give a mixture of products. Because of this, the salt of the acid corresponding to the anhydride is generally used in the Perkin reaction. Are you understand? Next we see coumarin preparation from ortho-hydroxybenzaldehyde. What? Coumarin preparation from ortho-hydroxybenzaldehyde. Now here we see we take ortho-hydroxybenzaldehyde and we treat it with Ac2Na and NaOH and we get compound 1. Here this CHO transformed into CH double bond CH, C double bond O, OCO, CH3, and when we treated this compound with dilute acid, we get CH double bond CH, COOH and OH. By ring closure, we get coumarin. Ortho-hydroxybenzaldehyde undergoes Perkin reaction and acetylation to give compound 1. Okay? This when treated with dilute acid undergoes followed by ring closure by coumarin. If anyone of you wants the mechanism of this reaction, please mention in the comment section and I will give you the mechanism. Okay? Thanking you for seeing my video.